Talk about graphing quadratic functions. And a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a is not 0. So you have to have an x squared in there somewhere in order for it to be a quadratic function. Now a can be positive or negative, it just can't be equal to 0. Every quadratic function forms a U-shaped graph, and that shaped graph is called a parabola. Okay. If a is positive, the parabola opens up. So it looks like a regular U. If a is negative, the parabola opens down. So an upside down U. The vertex is the lowest point on a parabola that opens up or the highest point on the parabola that opens down. This is the turning point in the graph. So the point where the graph changes direction. There's a line that passes through the vertex that divides the parabola into two halves. So basically it'll cut the parabola in half long ways, and that's called the axis of symmetry. And it's called an axis of symmetry because a parabola is symmetric, meaning that each half of the parabola is exactly the same shape and size as each other. Solutions to quadratic functions occur where the parabola hits the x-axis. Those can be called roots, zeros, or x-intercepts. So solutions, roots, zeros, and x-intercepts are all interchangeable terms for the solutions of the quadratic function. These are the values of x that will make these true. Now, if we graph using a t-chart, this will always work, but it can sometimes be very time-consuming. And the reason it's time-consuming is because you have to plug in values for x and find the value of y and then plot them on your coordinate plane. So I always start with 0 because 0 is easy. If I plug in 0, I get y is equal to 3 times 0 squared plus 6 times 0 plus 4, which will just give me a 4 because the zeros cancel the terms out. So x is 0, y is 4. So I'm going to plot that. That's this point right here. I'm making them kind of large so you can see them. If I plug in 1 for x, I get y is equal to 3 times 1 squared plus 6. Oops, oh, darn it. Look at that, I wrote down my 4 wrong. Let me start over. Apologize for that. Sometimes we all make little mistakes. That should have been minus 4, which would make this a negative 4, which will change my point to right here, 0, negative 4. So I apologize for that. If I plug in a 1, I get 3 times 1 squared plus 6 times 1 minus 4. So that's 3 plus 6, which is 9 minus 4, gives me a 5. So at 1, I am up here at 5. Before we keep going though, I want to indicate that this is positive, so we're going to have an up opening. So if I look at that, from here to here I went up. I'm not likely to turn around and go back down because I'm not going down, opening downward, I'm opening upwards. So if this is one side of the up, this would be the other side of the up. So I don't need to plug in any other values on the positive x. It will continue to go up forever. I'm going to start plugging in negative x's to try to find that point where it changes direction and starts to go up again. So I'm going to plug in negative 1. And if I plug in negative 4, I get 3 minus 6, which is negative 3, minus 4, which is negative 7. So I'm still going downward. So negative 1 is negative 7. But you see how we're much closer? So I think I'm going to find my turning point here pretty soon. Try negative 2. I get 3 times 4, which is 12, minus 12, which is 0, minus 4, so negative 4. And these match. So that tells me I'm in the right direction. So if I go negative 2, I'm back up here to negative 4. And because graphs are symmetric, I can hypothesize that when I plug in negative 3, I should get a positive 5. So I have 3 times 9, which is 27, minus 18, which is 9, minus 4 gives me a positive 5. So I found my symmetric U. And you want to connect your dots. Let me make that a little fatter so you can see it. You want to connect your dots, and you don't want a V at the bottom. You want a curve. And you know, it's not terribly pretty, but you get the gist. And there we have a parabola. Try another one. Make my t-chart with x's and y's. Like I said, I always like to plug in 0 first because that makes everything go away. So I get a 0 and a 3. So at 0, I'm 1, 2, 3. I'm going to plug in a 1 and see what happens. Oh, again, though, we want to look, we're negative, which means we're going to open downward. So we're going to look this like that. So if I plug in a 1, I get negative 1 squared plus 2 times 1 plus 3. So 2 plus 3 is 5, minus 1 is 4. I'm going to plug in a 2 and see what happens. So I get negative 4 plus 4, which gives me 0, plus 3 is 3, and I've already found my turning point. Now, yes, that's U, but I don't really know if it's going to go out more or if it's going to go straight down, kind of. So I'm going to do one more point on each side to see what happens. So I'm going to plug in a negative 1. And I get negative 1 minus 2, negative 3 plus 3, so I will get a 0. So at negative 1, I'm at 0, which tells me at 3, I should also be at 0. So 9, negative 9 plus 6 plus 3 is 0, so that worked out. And we could stop here, but if you'd like to get a better sense of the graph, you can keep going one on each side. I'm just going to go ahead and stop and connect my dots to make my U. And there's my graph. Now, we can graph a parabola using the vertex and the axis of symmetry, which is a lot less time consuming than a t-chart. Okay, the axis of symmetry is the line that divides the parabola into two equal parts. In this instance, my axis of symmetry is going to be the line that comes through right here. This is my axis of symmetry. Okay, my vertex is the highest or lowest point on the parabola. It's my lowest point if the parabola opens upward, and it's the highest point if the parabola opens downward. So in this instance, my vertex is this point right here. That's the lowest point. There's my vertex. And then the y-intercept is the point where the parabola crosses the y-axis. Okay. Right here is my y-intercept. That's where I'm crossing the y-axis. So I have a vertex, I have a line of symmetry, and I have a y-axis, or y-intercept. And you'll notice that on one space and one space, we have symmetry. If I come up to the x-axis, I'm a little past 2 spaces, or sorry, from the symmetry. I'm 1, 2, 3 and a quarter, 1, 2, 3 and a quarter. So we maintain symmetry throughout the graph, and we can use that symmetry to graph much easier. So first we want to find our vertex, our line of symmetry, and we want to talk about the domain and range. Your line of symmetry will always cross through your vertex. So here's our line of symmetry. Here's another line of symmetry. Here's another one, and another one. We're crossing through the center of the parabola. So our lines of symmetry are our axes of symmetry, are red. Our vertex or vertices are the lowest or highest points on the graph. Here's the vertex. Here's this vertex, vertex, vertex. The y-intercept is the point where we cross the y-axis. So I have a y-intercept here, a y-intercept here, a y-intercept here, and oh, I don't know where my y-intercept is on this particular one, but I'm gonna assume that it would be up here somewhere. We'd have to have this on a bigger coordinate plane to identify that one. Okay, the domain. The domain is all of the x values that will hold true. Now, while a parabola opens up or down, it will continue to expand infinitely as it travels along the y direction, and it'll spread out and spread out and spread out along the x direction. So the domain on these is going to be all real numbers. This is a symbol for all real numbers. And that will be the domain for every single one of these quadratics. Okay, those are all the x values that will make this plausible. It's our range that is limited. Okay, the range are all of the y values. And the range is going to be either y is greater than or equal to some number, or y is less than or equal to some number. And this will do with the vertex. In this instance, our vertex hits at the point 0, sorry, not 0, -1, 0, with 0 being our y value, and we open upward, so our range is y is greater than or equal to 0. Here our vertex hits at 2, 0. We open downward, so our range on this one will be y is less than or equal to 0. Here our vertex is at -2, 6, and we're opening downward, so our range is going to be y is less than or equal to 6. Here our vertex is at 3, 3, and we're opening upward, so our range is going to be y is greater than or equal to 3. So if you open upward, you're greater than or equal to. If you open downward, you're less than or equal to for your range. we were able to identify the axis of symmetry and the vertex and the y-intercept looking at a graph, but we need to be able to identify those algebraically as well. So those were the graphs. We'll do it algebraically now. So the formula for the axis of symmetry is x is equal to negative b divided by 2a. This is our b's and our a's from the quadratic equation. This is also the formula for the x-coordinate of the vertex. So this one little equation will give us two parts of finding these things algebraically. Now to find the y-coordinate of the vertex, we're going to plug in the x-coordinate. Okay. And to find the y-intercept, we're going to plug 0 in. Okay, so I didn't give myself enough room here. So what I'm going to do is I'm going to go through really quickly and I'm going to just eliminate these two. We're not going to use those because I didn't give us enough room. So we've got those out of the way. So I want to find the vertex, the axis of symmetry, and the y-intercept of each of these two. To find the axis of symmetry and the x-coordinate of the vertex, I'm going to plug in negative b over 2a. Well, b is 4 and a is 2, so I'm going to get 4 over 4, which is 1. Oh, sorry, negative b, negative 1. To find the y-coordinate of the vertex, I'm going to plug in negative 1 into this equation. So I replace my x's with negative 1. I get 2 times 1, which is 2, minus 4, which is negative 2, minus 3, so that's negative 5. And to get the y-intercept, I'm going to plug in 0, which will give me negative 3. So essentially the y-intercept is C. So my axis of symmetry is x equals negative 1. My vertex is the point negative 1, negative 5, and my y-intercept is negative 3. I'll try that on this one as well. My axis of symmetry, or my x-coordinate, is x is equal to negative b over 2a. So I get negative 6 over 2 times negative 3, which is negative 6 over negative 6, so that's a positive 1. My y-coordinate, I plug in that positive 1, and I get negative 3 times 1 squared plus 6 times 1 minus 5. So negative 3 plus 6 is 3, minus 5 is negative 2. My y-intercept is negative 5. So my axis is x is equal to 1. My vertex is the point 1, negative 2, and my y-intercept is negative 5. So that's how you'll find those algebraically, and you do need to know that because we have to find these to be able to graph. So let's talk about some things. First of all, we need to know, when do you graph linear, so a straight line, for example, using slope-intercept form or making a table of values or using intercepts, versus graphing a quadratic, which is parabola. So linear, straight line, quadratic is parabola. Okay, the standard form of linear equation, That's not how we write it though, is it? No, it's y equals mx plus b. Where m is the slope and b is the y-intercept. Of a quadratic, you're going to have an x squared. So this is really the indicator, x or x squared. Our degree, this is a first degree or a degree of 1. All variables are to the first power. Okay. And this one, our degree is 2, and that is our independent variable. Which is x, is squared. Okay, so examples, you might have 3x minus 10, or maybe you have 2x squared minus 5x plus 3. Things like that. Our graph is a line, and here our graph is a parabola. Okay, when you see this right here, this square, that's when you do the quadratic, so you're graphing a parabola. Okay, parabolas have minimums or maximum values. So what happens is when a is less than 0, so a is negative, the graph will open down. Like so. And you have a maximum. And your maximum is the y value of the vertex, or the y coordinate. Okay. If a is greater than 0, in other words, a is positive, your graph opens up. Like so. And your vertex is the lowest point, so you have a minimum. And that is the y value, again, of the vertex. So your minimums and your maximums are the y value. And this is also what determines your range. These two. Okay, if you have a maximum, your range is y is less than or equal to the maximum. If you have a minimum, your range is y is greater than or equal to the minimum. Okay, so we want to determine if it has a minimum or a maximum value. We're going to state that value, and then we're going to state the domain or range. Okay, so the first thing we want to do is a greater than or less than 0. Well, a is less than 0, so we're going to open downward, so we're going to have a maximum. Okay. The second thing we want to do is we want to find that vertex, so we're going to use x is equal to negative b over 2a. So I have 4 over 2 times negative 2, so that gives me a negative 1, and then I'm going to plug that in. So I have negative 2 times positive 1, so negative 2 plus 4 is 2, plus 6 is 10. So my maximum is 10. And finally, my domain and my range. My domain on a quadratic is all real numbers. My range, in this case, since I have a maximum, is less than or equal to that maximum, 10. Okay, your minimum or your maximum determine your range. So let's do the next one. Again, our first step is a greater than or less than 0. A is greater than 0. So we're going to open upward. So we're going to have a minimum. So I want to find that minimum. So first I'm going to find the x coordinate. So I have a -4, so that's +4 over 2 times 2. So that's 4 over 2, so that's 1. And then I need to plug that in to find the y value. So I have 2 minus 4 is -2 minus 1, so that's -3. So my minimum is -3. My domain on all of these will be all real numbers. And my range, because I have a minimum, I'm going to be greater than or equal to that minimum. So again, my minimum is my y value of the vertex, which determines my range. So if we want to graph an equation using the axis of symmetry, and I'm going to be bouncing back and forth between these two pages so that we have enough room. Okay, and I don't even know if it's 9 steps altogether, I just wrote that many. So we've got our equation. So the step 1 is going to be to find the axis of symmetry. Okay, so I'm going to do that part right here. -b over 2a. So I have -4 over 2 times 1. So that's -2. So it's x equals -2. That's my axis of symmetry. Okay. My next step is going to be to plot the axis of symmetry. Okay. So x is equal to -2. So what I want to do is I want to come over here to -2 and I want to draw a line straight up and down. Oops, I made it a little crooked. Let me fix that. Okay, apparently I'm not very good at fixing crooked lines. There we go. So here's my axis of symmetry. I've plotted it. It's at x equals -2. Nope, I messed it up. I moved it over. Now it's at x equals -2. Okay. The next thing we want to do after we've plotted our axis of symmetry is we want to find the y value of the vertex. Okay. We already have the x value from step 1. Okay, so here's my x value. So here's step 3. Let's put this was step 2. I'm going to plug in -2. And I get 4 minus 8 plus 3, which gives me -1. So after I've done that, I'm going to, sorry about that, I'm going to plot the vertex on the axis of symmetry. Okay, my vertex is the point -2, -1. Well, my line -2 is already taken care of, so I just need to put a dot at -1 on that line. So here's my vertex. Step 5, once I've plotted my vertex, I've got that taken care of. I've got my axis of symmetry. I now need to find my y-intercept. Okay, so that's step 5. And to do that, I plug in 0. Let me actually write that on the other page so it's not taking up space here. So y is equal to 0 squared plus 4 times 0 plus 3, which is 3. And I know that I've also told you that that's just c, but if you forget, you can always plug in 0 and use that information that way. Once we've found our y-intercept, we want to plot it. Okay, so my y-intercept is 3, so I'm going to come here to 3. I'm going to put a dot right there. Okay. Then I need to count the number of spaces between the axis of symmetry and the y-intercept. Because remember I said we're symmetric. So I have 1, 2. 2 spaces between y-intercept and axis. Okay. Finally, I'm going to count the same number of spaces on the other side of the axis. And put a dot. Okay, so I was 1, 2 this way, so I want to go 1, 2 this way, and I put a dot. Okay, now I have 3 dots. I have my vertex, my y-intercept, and the symmetric point. And so my final step is going to be to connect the dots with a U. We don't want a V, we want a U. So I usually come in and I kind of do that at the bottom to make sure I have my U. And you want it to sort of open as it goes. And again, we're not perfect, we don't draw perfectly, and that's okay. You get the idea. There's our parabola. So let's try another one. You'll see that it's a lot less intense going back, we're not going back and forth. So again, we're going to find the axis of symmetry. So -2 over 2 times -2. Yuck. Okay, so that's 1/2. This is okay. What I'm going to do here is, in order to make this graph look better, I'm going to start counting, and I'm going to change the scale. I'm going to get rid of these numbers here, and you're allowed to do that. You can change the scale. Just because there's lines on there already doesn't mean each line has to equal 1. I could have one line equal 10, or I could have one line equal 1/10. So what I'm going to do for this, to make this nicer, is I'm going to have each line equal 1/4. So I have a fourth, a half, 3/4, 1. And then 1.5. Let me make that clearer. So I've got 1, 2, 3, 4. There's 1. 1, 2, 3, 4 is 2. 1, 2, 3, 4 is 3. 1, 2, 3, 4 is 4. I'm going to do the same thing coming up. I've got 1, 2, 3, 4 is going to be 1. 1, 2, 3, 4, 2. 1, 2, 3, 4, 3. 1, 2, 3, 4, 4. We're going to spread out that way. That'll make it easier to plot 1/2 because 1/2 is actually going to be 2 lines over, as opposed to halfway between one and another. So I'm going to plot my axis of symmetry at the 1/2 line. There's my axis right there. Then I'm going to find the y-coordinate by plugging in a half. So I'm going to do -2 times 1 half squared plus 2 times 1 half minus 1. That's -2 times 1/4 plus 1 minus 1. Those will cancel each other out. -2 times 1/4 is going to be -1/2. So my y-coordinate, my vertex, is 1/2, -1/2. And again, that's okay because I made each line a quarter, so that's just 2 places. So -1/2 will be right here. Now I need to find my y-intercept. I plug in all zeros. Or again, it's just C. So it's -1. -1 is going to be 4 down. So 1, 2, 3, 4. That's my y-intercept right there. And because this is negative, I know we're opening down, so I know we went in the right direction. And 2 spaces over, I go 2 more spaces over, and I connect with the U. Now earlier on another video I had said that you can solve these by graphing. Okay, so in order to find the solutions by graphing, sometimes these are estimates and sometimes we land perfectly, but we just find the x-intercepts. So where our parabola hits the x-axis. Okay, so if we come back to our graph here, and we're a little bit kind of fat, but that's okay. Yeah, that's not a great one. Let's do a better one. Hold on one second, okay, got us a graph. Gonna get us an equation. We're gonna have x squared minus 2x minus 8 equals 0. And I can either make a table or I can graph this with my axis of symmetry. So I'm going to use axis of symmetry, -b over 2a. So I get 2 over 2, so I get 1. So my axis of symmetry occurs at 1. So bring that down. And then my y-coordinate of the vertex, I'm going to plug that 1 in, and I get 1 squared minus 2 times 1 minus 8. Oh dear, that gives me a -10, doesn't it? Alright, well we'll just change the scale. Like I said, we can do that. Instead of each one of these being worth 1, I'm going to make them worth 2. And because I did that, I have to move halfway-ish. So that's approximately halfway. Can't get exact on this one, but that's okay. My y-coordinate is going to be -10, so I have -2, -4, 6, 8, 10. So right here. My y-intercept is -8, which would be right here. So I'm here and here. And I'm going to draw my graph. And I want to try to be kind of careful with it. You don't want to go too far. Just sort of come up. You need to cross the x-axis. And I'm going to come up this way, and I'm going to try to keep it the same sort of fatness all the way up. And I am crossing at 4. Oh, I went too far on this side. That's not, oh darn it. That's not even. I went too far over here. evaluate that way. So I'm crossing at 4 and negative 2. So my solutions are going to be negative 2 and 4. Again, though graphing is an approximation, this is not the best way to solve a quadratic equation because you can't always guarantee that you're going to get the correct answer. I recommend completing the square quadratic formula or factoring if you need an exact answer, and graphing if an approximation is okay.